Hi again, everyone. Welcome to Primary 6 Science with Chapter 6 with the topic of physical and chemical changes. Let's start. Now, in this lesson 1, we are going to focus on physical changes. So, this learning aims to know about which physical changes can be reversed and describe how these physical changes occur. Now, if we see from the picture for the chapter trigger, so let's see one of these questions. How does the fire change the trees in the forest? So first of all, what is happening to the trees in the forest? So you can see that the trees are burning. So can we undo these changes? So for example, after it is burned, then the trees after the fire is out, then the trees will be back as usual as previously. Well, the answer is no. So how does the fire change the trees in the forest? So are there new things formed from these changes? Well, we know that smoke, you see, there are so many smoke and also ash are, are formed. So the fire changes the trees by using heat, okay, using burning, and then it will change into smoke and ash, okay. So can we undo these changes? Yes, I cannot. So are new things formed? Yes, smoke and ash. So before we continue, please open page 80 of your book, okay, student's book. So, and try to think of this sentence. I wonder if broken glass can be changed back into its original form. So can we change the broken glass back to its original form? Yes, the broken glass can be pieced back together. You use glue, for example, but it cannot change back to its original form where there is no cracks or nothing. So it cannot. So, and then if you say that, yes, it can be back to its original form. Well, probably if you understand how you're going to go through the long process of heating, cooling, and then you start forming the glass again from the very beginning, or what we call recycling, then yes, you will get a broken glass back to its original, which in this chapter we are not going to talk about it. That is too far. So we are going to focus on the part where the broken glass cannot be changed back to its original form without any long process. So it is not possible to change back. Okay. Now let's see the main concept of the physical changes. If you see the pictures, okay, what are the two states of candle wax shown in the picture? Well, good job. If you see there's some liquid in the middle and also solid. So there are two states of candle wax shown in the picture, solid and liquid. How can the candle wax change from the solid state to the liquid state? Okay, how can we change the candle wax into the liquid state? Yes, good job, by heating. Now, how can the candle wax change from the liquid state to the solid state? So when it has changed to a liquid, and then we want to change back into solid, what can we do? Yes, very good. We can use cooling. So by cooling, yeah, the liquid, the candle wax that has changed to liquid will be turned back into solid. So remember, melting and the solidification of candle wax are physical changes. So it can go back and forth. So in conclusion, yeah, we can change the substance back to the way it was before the change took place. Now, let's think about this question. Are these physical changes of the candle wax reversible? The answer is yes. Why? Because the candle wax can change back to the way it was. So remember, if we say physical changes, that means the the thing or the substance can change back the way to the way it was. So like back and forth, it is reversible. So what are some of other physical changes that are reversible? Can you think about it? Well, actually, we can see like evaporation and condensations are physical changes that are reversible. Why do we say that? Because you see, during condensation, right, and then all the water vapor goes up, and then it will condense into cloud, right, and then it will fall down as the rain, and then it will go up again through evaporation and also boiling. So all of these are like a water cycle. So this water cycle is one of the physical change that we call is reversible. But now wait a minute. Let's see this one. We have to know that some physical changes can be irreversible too. Let's look at the picture on the right. What has happened to the piece of paper? Can we get back the original piece of paper? Well, if we glue the paper because after it is torn, well, it can, what is that? Like being not separated again, but we still cannot get back the original piece of paper. And then what type of change happens when you tear a piece of paper? Is tearing a piece of paper reversible? Well, physical change happens, but it is irreversible or not reversible. Okay, so that's the same type of change happen when you fold a piece of paper. Well, folding paper is a physical change, but it is reversible. Why you say it is reversible? Because the paper remains as one whole piece, and we can unfold it to change it back to its original shape. So that's why we must understand, everyone, physical changes, there are two kinds. Okay, it is reversible and then irreversible. But still, what we want to say that the physics changes. Okay, so that's why it is called physical changes. So what are some other physical changes that are irreversible? Let's see an example. Well, when we break a mug or a glass break, it is actually a physical change that is irreversible. Now let's try to do this activity by classifying these physical changes into the correct groups, which is reversible and irreversible. Okay, let's see the first of breaking a plate. Is that reversible or irreversible? Okay, good job. The question is irreversible. Now, the next one, dissolving sugar. Okay, for dissolving sugar, do you think that is reversible or irreversible? The answer is, that's good, reversible. Okay, dissolving sugar. Okay, because you can obtain the sugar again later. Okay, and then scratching paper. Do you think that is reversible or irreversible? The answer is Reversible. Very good. So let's continue. Now let's discuss this one question. Do metals undergo physical change that are reversible? The answer would be yes. Metals undergo physical changes that are reversible. Because when we melt or we heat the metals and it melts in a specific or certain melting point, that means it will become liquid. But if you put it, you put it in a special container to ship the metals back into metals, like when we are making utensils and so on, that means it will become, metals again. So that's why we are saying that the physical changes in metals are reversible. Now let's wrap up by looking at these sentences and try to tick the correct box beside each sentence. You have to give the tick to the correct answer based on the sentence given. Now let's see the first sentence. A physical change can be a change in state or shape of a substance. Okay, what do you think the answer would be? Okay, what do you think about physical change? Is that a change in state? Yes, definitely. And do you think that can be a change in the shape? Good, yeah, because if we see like the wrinkled paper and then also the wax, so the answer is true. Nice. Okay, next, the next question. All physical changes are reversible. Is that true, everyone? All physical changes are reversible. Remember, just now, the wax is reversible, but the torn paper is not reversible. So, all physical changes are reversible. The answer should be false. Very good. For the homework, don't forget to have research on the physical changes that are involved in the recycling of glass and aluminum. You can find out through Google or maybe YouTube. Find how glass and metal, such as aluminum, can be recycled into new objects. And then please also find out about physical changes that are involved in the recycling of these materials. So, if I see you again later in the class or with your teacher, you can try to discuss about this, okay? Now, lesson 2, dissolving. In this lesson 2, you're going to use the particle model to describe how temperature affects solids dissolving in liquids. Now, to trigger this lesson, let's see the example of this picture. Okay, you can see that many times we put in the effervescent table and that it will dissolve faster in which one? In cold water or in warm water? So probably you're going to say warm water. Now, how do we know that it is true or not? Let's see about how a solid dissolves faster in a liquid. Before we do that, please don't forget to open your page 85 of your student book. And don't forget to recall a little bit about your lesson in primary 5 about dissolving. How can we make a solid such as salt or sugar dissolve faster in water? Now, you might be aware that using hot water or stirring the liquid can make a solid dissolve faster. So this might help you learn about the concepts. Let's continue. So the main concept of lesson 2 is that dissolving is the process by which a solute is mixed with a solvent. So what happens when a solute dissolves in a solvent? The solute particles move between the solvent particles until they are mixed evenly. So where is the solute after it has dissolved in the solvent? It is present in the solution. So what are the examples of solution formed by dissolving a solute in a solvent? Okay, so for example, the salt solution is formed by dissolving salt in water. So that's why we come up with our last question. Do you think dissolving is a physical change? The answer, yes, because there is actually no new substance is formed during dissolving. So the substance is only actually the same, but it has dissolved with other substances. So that means we can say that the dissolving is actually a reversible change because why? We can get back the solute and the solvent by separating them. But if we increase the temperature of the solvent, that means what happened? The solute will dissolve faster. So you can try at home. For example, you have a glass of water, and then the other one is the what is that? A glass of hot water. If you pour like sugar or yeah, I think sugar or salt in it, and then you try to stir it, you will see that the glass with the hot water will dissolve the sugar faster. So that means we can say that the temperature increase will what is that make it possible for the solute to dissolve faster, and then more solute will dissolve in the solvent. Okay, now let's see this activity. Which beaker do you think has a higher temperature of solvent? See from solvent particle and then solute particle. Okay, and then this one, the right one is the solvent particle and then the solute particle. So the question will be, if we hit a solvent, what will happen to its particles? So the solvent particles will have more energy and move faster. So how will the movement of the solvent particles affect a solute dissolving in the solvent? So the solvent particles will be more able to break up the solute particles into the solvent. So the solute will dissolve faster, more solute. So that's why we will have more solute in a solvent that is having a higher temperature. So if we see, we have to know that there is an effect of temperature on solids dissolving in liquids using the particle model. And then you can see also, so the diagram on the right will have, see, you can see from the number of solute, which one has more solute. If we see from the picture, it should be on the right. So that means if it is on the right, we can say that the beaker on the right has a higher temperature of solvent. So that's good, okay? Now let's see. Now can solids dissolve in cold liquids? Well, let's see. Imagine if you pour, okay, you pour the sugar, yeah, rock sugar into cold water and you stir it. Do you think that a solid can dissolve or the sugar can dissolve in cold liquids? Hmm, yes, probably yes. However, because the temperature of the liquid affects how much a solid can dissolve, so we'll think that the cold water will reduce or will slow down the dissolvent or the dissolve process of the solid into liquid, and then will be less solvent in the solute. So what will happen if you keep adding salt to a glass of hot water? What do you think? So, for example, you have dissolved salt and then you keep on, like pouring the salt again and again. So, do you think the salt will dissolve again and again and will continuously dissolve? Well, the answer is no, because there is a maximum of a limit for salt or any solvent to dissolve. So, if you keep on pouring, okay, adding salt to a glass of hot water, after some time, okay, no more salt will dissolve. Now, remember that dissolving can occur at a range of temperatures. And then let's see the question right now, yeah, and then compare with the previous question. So why does more salt dissolve in warm water than in the cold water? Can you think of the answer? Well, yes, the answer will be, yeah, you see the warm water, remember the temperature, that means the warm water has higher temperature than the cold water, or maybe just the water with room temperature. So the logic will be the particles in warm water have more energy and move faster, breaking up the salt particles more easily. So that is why, okay, we can say that more salt will dissolve in warm water than in cold water. Now don't forget to complete your homework worksheet 1 about the physical changes and dissolving. Now let's go to the next one about lesson 3, chemical reactions. In lesson 3, we are going to learn that in chemical reactions, substances called reactants interact to form new substances called products. Now we can observe and describe evidence of chemical reactions. Now, to trigger this lesson, we can start by looking at the picture on the right. What picture is that? Yes, that is a candle wick. So what happens to the candle wick? Okay, we can say that the candle wick, okay, the candle turns black, or a black substance is formed. So can we reverse this change? You see, before we turn on the candle, okay, the candle rope is still maybe probably white, but after you light it on, the color is black. So can we reverse this change? What do you think? Can we reverse this change? Well, the answer is no. Because why? Because the candle has changed in color, the candle wick. The candle wick has changed in color, so that means it is a chemical change, because it is not again the physical change, and it is a chemical change in color. That means we can say that it undergoes a chemical change. So is a new substance formed? What do you think? Yes, a new substance has formed. And how do we know? We know because the candle wick has changed in color. So probably, or the composition should have changed. Now let's open page 89 of the student's book, and let's put on this thinking cap while thinking. I wonder how I can tell that a chemical change is taking place. So are there any signs when a chemical reaction is taking place? Well, you might be aware that new substances that are different from the starting substances are formed. So we have to understand that when a chemical change is taking place, that means a new substance will be formed. Now, which two changes involve chemical reactions? Tick the correct boxes. So you can see in the first picture, we find there is a an egg which we fry. Okay, we fry the egg and then it turns into, yeah, sunny side up egg. Okay, from liquid to physical or solid. So, and then the next one is boiling water. When you boil water, the water creates like bubbles, okay? And then it will, what is that? In turn, will change to water vapor. But we know that there is a water cycle, that the water will change back the water vapor after it meets the room temperature. It will turn back into water. But the burning paper, when you burn paper, the paper will change its composition and then change into another substance. Yeah, it will turn to ashes. So we can say that is actually chemical reaction. So from these two changes, which one involve chemical reactions? The answer will be frying an egg and burning paper. Meanwhile, the boiling water should be physical change. Now, the main concept of the chemical reaction is that chemical reactions involve substances such as reactants or known as reactants reacting together. So these new changes, what do you observe on the car? So you see that the car has become rusty. So is there any new substance formed? Well, there is a layer of brown substance on the car, right? It is rusty. So this brown substance is a new substance. So we can say that it is chemical change. So what type of change has the car undergone? Definitely chemical change. Now, what do you think are the reactants and the products of this chemical reaction? So the reactants are the things that create or cause the result of this chemical reactants that turns into other new substance is the iron of the car's body, water and oxygen in the air are the reactants. But the rust, okay, coming from the iron reacting with water and oxygen is the product. So can we say that is the chemical reaction reversible? Do you think the car, after becoming rusty, and then we do some things to the car, that it will change back or reversible? Well, the answer is no. We cannot get the reactants back after the reaction has taken place. Why? Because it has changed into new substances. So we must realize that the new substances formed are known as products, and the most chemical changes are reversible. So, what are some other examples of chemical reactions? Well, if we see when we cut apples and then the apples after some time turns brown, and then we burn candles and wood together, and then the coal packs. So those are the examples of chemical reactions. Now again, let's see the picture of this glass, and you put an egg into the glass filled with water. So imagine if we fry an egg or we bake an egg. Do you think that we involve chemical reactions? Yes, definitely, because we have also discussed that in our previous slides. But how do we know that a chemical reaction has taken place when you fry an egg or bake a cake? What do you think? Yeah, you may say that because the color changes, but you have to know too that like when we bake a cake, okay, the shape have changed. Maybe you can say that it's a physical change, but because there is a change of color, for example, you put the dough, okay, from the cake and then it turns to brown, we can say the color changes. That's why it has undergone a chemical change, but actually we can say from other things too. So if we see the glass, actually it is filled with vinegar, vinegar, right? The vinegar, and then you put an egg into it. So what can we observe from the eggshell? So we can see that the eggshell has, what is that? Produced bubbles of gas. Okay, a gas is being produced when we put an egg into a glass of vinegar. The question will be next, is there any new substance formed? Hmm. Well, of course, definitely yes, because the eggshell has reacted with the vinegar to produce the gas carbon dioxide. So, are all these chemical changes reversible? Hmm. No, because we cannot get back the reactants even after the reactions have taken place. So we have to see not only a gas is being produced, there is a change of color and change in temperature. Now let's watch again and then let's see if we can, what is that, burn. Okay, let's see the chemical reaction shown in the video. So when we try to see the example of rising of iron and photosynthesis, so there is a change in color when the iron rusts. A gas, oxygen, is produced when plants carry out photosynthesis. But in this picture, we can see that when you burn or heat the, what is that? The sugar, this one is a sugar or maybe salt, and if you heat it on the fire, you will see that there will be a chemical reaction taking place. Because why? The substance will change into the new one. Okay, that's why you like to call it like the sugar. If you heat it, it will become caramel. Okay, the caramel is actually a new substance, and it is, what is that? Is that reversible? Okay, no, that is not reversible. So we can say that not all chemical reactions are irreversible, but also not all physical changes is reversible, and there are some that are irreversible. Okay, now let's try to answer the question, the wrap up. Okay, get the students, get you to answer these questions. Let's see. From the first number and the second number, you can try to think about the answers first by thinking what we have learned so far. Okay, and then we will try to answer it. Okay, have you taken your time? Okay, let's check number one. Blah 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 reactions involve substances called blah 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 reacting to form new substances called. Okay, so for number one, okay, it is the chemical reactions, okay, involve substances called, remember, good job, okay, the answer is reactants. These reactants will react to form new substances called, remember just now, the new substance are called products. Very good. Now, number two, to find out if a chemical reaction is taking place, we can observe these signs. Remember just now, what do we have? Yes, we have color change, temperature change, and formation of a what? Of a new substance, yeah, or we can say gas. Okay, now let's see this one again. If you have time later when you bring your phone, maybe for a quiz, and then we will know that if the students have understood or you have understand about the lesson. Now, don't forget to complete your homework worksheet 2 for chemical reactions. Okay, now these are the acknowledgements again. You can check the link to understand more about this chapter. So thank you guys for staying with me during 34 minutes. I hope to see you again in the next chapter of chapter 7. Bye bye. See you next time.